All right, now that we have a little idea about radians and arc length and sector area and those kind of things on a circle, now we're going to start talking about the trig, some of the sine, cosine, tangent, and then all the reciprocals as well, cosecant, secant, cotangent. And all of this section is going to be without a calculator. So what we have to do first is we have to review our 30, 60, 90s, 45, 45, 90s. So if you look at this first little row here, I have the 30, 60, 90, 45, 45, 90 all set out the way we've learned them and the way we've dealt with them all year, really. Now let's take a look at a couple examples. So 1A, if you know that the side across from the 30 is 5, then the one across from the 60 should be 5 root 3, and the one across from the 90 should be 10. Okay, same goes on a 45, 45, 90. Now this one's a little bit trickier because on this one, the 10 is the x root 3 or x root 2 side, excuse me. So to get x by itself, we're dividing by root 2. And then as you probably already guessed, we can't leave the radical on the bottom, so we've got to write it as 5 root 2. So on this problem, x is 5 root 2, and since it's isosceles, y is also 5 root 2. So really get used to the 30, 60, 90s, 45, 45, 90s, and how they all work. All right, this chart down here, it gives you all 6 trig functions, sine, cosine, tangent, and the reciprocals, but all with x's, y's, and r's. So we're used to seeing it as SOHCAHTOA with o's and h's and a's. Now we're going to talk about x, y's, and r's. Okay, so let's relate our circle to the xy axis here. Okay, we know this is the x-axis, we know this is the y-axis. So if I grab any triangle I want, I'll draw one in the first quadrant here. My theta in there. All right, so the x value on this triangle is on the x-axis, that kind of makes sense. The y value is here, and the radius of the circle is this guy right here. So instead of opposite, adjacent, hypotenuse, now we're going to talk about the x, the y, and the r. Now the r we can find by just doing Pythagorean theorem if we ever don't have it. Okay, so let's look at the first one. This one says sine theta is y over r. Well, we know sine is opposite over hypotenuse, but if we look at this triangle here, opposite is y, and the hypotenuse is an r. So hopefully that y over r makes sense. And if you go through each of the 6, all of those should also make sense. Okay, let's try an example. So number 2 says, let theta be the acute angle in standard position. So if I start drawing it in standard position, remember what that means. It means the initial side is on the positive x-axis, and whose terminal side contains the point 43. Okay, so we have to remember that the point 43 is in the first quadrant. So positive, positive. So if I draw this out here, 4, 3. Okay, now just drawing the angle is nice, but we really need to make a triangle. So we're going to connect it down to the x-axis, and then we can see that this distance, the x value is 4, the y value is 3, and if we did Pythagorean theorem, we'd get 5. So the problem says find all 6 trig functions. Well, let's not find all 6. Let's just find a few. So if I say sine theta, and theta again is your reference angle in here, is opposite over hypotenuse, or y over x if you think about it that way. And then if we want to do the reciprocal, cosecant theta would be 5 over 3. Okay, so then you could list out all 6 that way. Let's try another example, just a little bit harder this time. So if I do the same kind of instructions, except the point is negative 5, 3. All right, so I put that on my circle. Negative 5, that's the x value is a negative, y value is 3, positive. So it's got to be in the second quadrant over here. So if I draw this out, label up the sides, I'll get negative 5 here, 3 on the y. All right, now if I do Pythagorean theorem for this one, I get a not so pretty hypotenuse. So the radius, the hypotenuse, is root 34. So just remember, when you start doing your trig functions, let's do one here. So if I said sine theta, it would start by saying 3 over root 34. But just don't forget to rationalize all of these. Every single one of these should be rationalized. So this should be 3 root 34 over 34. All right, and again, you could go through all 6 if you wanted to practice. Now let's find some of the trig functions of actual angles. All right, so not just saying theta anymore. Now we're actually going to give a number. So if I look at this number 4, find the 6 trig functions of 315 degrees. Okay, so let's just review. 315 positive should go counterclockwise around my circle. All right, and if I pass all my marks, so it would be 90, so let's just kind of mark these as we go. 90, 180, 270, 360. So 315 should be hanging out here in the fourth quadrant. All right, now with all of these, we want to find the reference angle. So if I connect that terminal side to the x-axis, always to the x-axis, and I know that 360 would have been all the way around, now I can say my reference angle in here is 45 degrees. All right, so now what we're doing is we're labeling the triangle as though we would label a 45, 45, 90. And if you look at the front side, you could remember it as x, x, x root 2. Well, x can be anything, so why not choose a nice number like 1? How about 1, 1, 1 root 2? Okay, remember, trig is just a ratio of side lengths. So if your favorite number is 10, you could have said 10, 10, 10 root 2. Doesn't matter, it all reduces the same. Okay, so I like choosing 1. Okay, now look at my picture. Remember, you're in the fourth quadrant. So remember, if you have any negatives, you do have to come in and place some negatives. All right, the x value is positive. The y value would be negative. Okay, so it's -1 there. And then remember, this is a note to remember always, the radius or the hypotenuse, always positive. Okay, so no matter what quadrant, the radius is always positive. So again, it says find the 6 trig functions. Let's just find one. Let's say, I don't know, let's do cotan. So cotan of 315 would be the adjacent over the opposite. So adjacent over opposite. And then I reduce that, I get -1. Okay. All right, let's try another one. 210 degrees, this time with a negative. So here's my circle. Hang on, let me give myself a little more space. Here's my circle. We're going to go clockwise this time. So -210 should be past the -180 mark and over here in the second quadrant. And if I draw the reference angle in, so connected to the x-axis, this is my -180 mark. So the difference between those two angles should be 30 degrees. So now I'm talking a 30, 60, 90. And again, we could label it x, 2x, x root 3. We could definitely do that, but why not just choose a nice number? I'm going to choose 1. So 1, 1 root 3, and 2. Okay, now we're in the second quadrant, so this time the x value is negative. All right, now let's answer the question. Sine, once I build my triangle, sine -210 degrees should be opposite over hypotenuse, so 1 over 2. Let's try one in radians. So now we're talking 5 pi over 3. Now we're talking radians. Okay, so I'm going to draw a pretty big picture. I don't know how much space you guys have, but I'm going to draw a pretty big one so I can label it nicely, because radians still kind of new to us. Okay, so here's 0 radians. Here's pi over 2, or 90. Here's pi. Here's 3 pi over 2. Here's 2 pi. Okay, so each quadrant is half a pi, if you think about it that way. Now, 5 pi over 3, if I write it as a mixed number, would be 1 2/3 of a pi. So if I have to find 1 2/3 of a pi, well, we know where 1 pi is, and another half would be here, and 2/3 is bigger. So 1 2/3 is going to be hanging out in the fourth quadrant. Okay, now the reference angle. If this is 5 pi over 3, and this is the 2 pi mark, or 6 pi over 3, so we have common denominators, then there's a 1 pi over 3 difference. So the reference angle is pi over 3. And it might be a little bit easier to think about in degrees. Pi over 3 is the same as 60 degrees. So here's my 30, 60, 90 again. And I'm going to label it with a 1, a root 3, and a 2. And again, the y value negative. Okay, so tan 5 pi over 3, tan 5 pi over 3 is opposite over adjacent, or just negative root 3. Okay. All right, now I want you guys to try number 7. And just remember, negative angles go clockwise. All right, now let's tackle some weird ones here. Okay, I'm going to draw a picture. Maybe I can even scooch a little room down here. I'm going to draw a picture. Okay, remember the XYR thing we drew on the previous page? I'm going to draw it again, so I have it right in front of us. Okay, theta, x value, y value, radius. Okay, so sine, if I look at number 8, should be the y value over the radius. Number 9, cosine, should be the x value over the radius. And cotan should be the x value over the y value. Okay, so now what we have to do is we have to figure out what in the world happens if the angle is on one of the axes. Okay, so picture 90 degrees. 90 degrees is straight up and down right here. Okay, so I can't really draw opposite adjacent. I can't do any Pythagorean theorem or anything like that. Now, we do have to remember we have a unit circle. So unit circle means radius 1. So if I have a point right on the axis here, the coordinates of that point are 0, 1. In other words, the x value is 0, the y value is 1. Now again, radius is also 1. So if I have to fill in this ratio of the y value to the radius, well, it would be 1 over 1. So sine 90 is 1. All right, I'll try number 9, then I'll have you guys try number 10 on your own. Okay, negative 180 would be here. And on a 1 unit circle, the point would be negative 1, 0. And again, radius 1. Okay, so now I know cosine is x over r, so now I can say negative 1 over 1, or just negative 1. All right, you try number 10. Okay, so now I'm going to try one in radians, so I'll try, I don't know, let me try number 12, and I'll have you guys try 11 and 13. So if I do secant, now if I go back to my triangle idea again, secant would be the radius over the x value, because it's the reciprocal of cosine. So 3 pi over 2 would be right here. And again, in radius 1 triangle, that coordinate would be 0, negative 1. So if I fill in the secant values in, the radius is 1, okay? The x value is 0. Well, what happens here then is we say undefined, because you can't have 0 on the bottom. Now, when we do graphing in a couple sections, that means there's going to be an asymptote there, and we'll talk about that later. Okay, so you try 11 and 13. All right, let's tackle one a little weird, something like number 16. If I want to have two things that I'm doing, I have a secant pi minus a cosecant pi over 2. Okay, so secant, remember, is the y value, the radius over the x value, and cosecant is the radius over the y value. Okay, so let's draw two triangles here. So pi is over here, be negative 1, 0. Pi over 2 is up here, 0, negative 1. Again, don't forget, radius 1, radius 1. Okay, so if I want to do radius over the x value for pi, it would be radius 1 over x value minus radius 1 over y value. Okay, so for this problem, I have negative 1 minus 1, I get negative 2. All right, you guys try 14 and 15. And then the next 3, I'm not going to do for you. I just want you to practice it. So you're using a calculator to 2 decimal places. And all I want you to get used to doing is when you see a degree mark, like in number 17, hit your mode button, make sure you're in degrees. Okay? Whereas 18, in your mode, no degree mark, so it must be radians, change it to radians. So try those 3 right in a row, just give me 2 decimal places.